what did everyone get for their answer? Let's start there. Well, good morning, everyone. Today is Wednesday, November the 10th. So we got 6, 6, 6, 5. X equals 6 is correct. X equals 6 is correct. All right. Anybody want to go on mic and take us through what they did? Nobody? If you plug in 5, you'd see it wouldn't work. That's not true. Plugging in 5 into X, like 5 isn't correct, but plugging in 5 times 2 is 10, 10 minus 4, is definitely not this, but I don't know if that's as clear to see, at least with the knowledge we have right now. Even if you plugged in 6 is the right answer. 2 times 3 is 6, 6 minus 4 is, 12. 2 times 6 is 12. 12 minus 4 is 8. So log base 2 of 8 equal to 3 log base 2 of 2. Maybe also not as clear to see if it's even the right answer, but it is. All right, so there's a few choices we can do. Now, what did some of you do on the right-hand side? There's really 2 choices we could have made. Dividing by 3 is probably not a good choice because then you're just introducing fractions into a log problem. Not that fun. Yeah. You probably want to avoid dividing unless it cancels something out on both sides. Turn the whole log into a 1. Yeah, so that's one way to do it. So this log base 2 of 2, we could have, remember, this log base 2 of 2, this equals 1 because the base and what you're logging are the same numbers. So that's I guess a property that when these match, it equals 1. And then 1 times 3 is just 3. Does everyone see that? Okay, now what? I'll base 2 both sides. Yeah. And 2 cubed equals 8. And then from here, it's super simple problem. Okay. Did anybody do it a different way? Because there's another way to do it. The 3? This 3. So log base 2 of 2 becomes 1. So, and then 1 times 3 is 3. Did anybody move this coefficient to become an exponent to this log? We could have, but nobody did it that way. Let me just show that. So we could have had the left side and then the right side. And now we are allowed to base both sides. So we're going to base both sides with a 2. And then we get 2x to the 2x minus 4. And then we get 2 cubed, which is 8. And then we get to see the same work from that point. So 2 ways to approach the problem. We got this one correct. X equals 6. And Brady, do you see your mistake though? Okay. Oh yeah, these problems are really simple if you do it the right way. Of course. All of this stuff is simple if you do it the right way. Okay, so today's stuff, properties of logs. We'll be expanding and contracting logs and natural logs. So get your paper, pencil, calculator if you need it. All right, properties. There's only actually 2 properties that are new to us. Jumping down to this last one, we all know that when you have an x, so log base b of a to some exponent, we all know that we can take this exponent and we can move it in front to become a coefficient, and vice versa. If you have a coefficient times log base b of a, we can move this back to become an exponent. So we already know this one. Natural log, it's the same thing, but instead of log, it just says natural log. What is natural log? We went over it yesterday. How can I write natural log as a log? Yep, log base e. Yeah, natural log is just log base e. All right. Going back to these first 2. So when you have log base b of m times n, let's say it's 3 times 2. When you have log base b of 3 times 2, this expands with addition. So multiplication becomes addition. And by the way, if you're wondering, we don't need these parentheses. Oops. Like I don't need these, because even without them, it means the same thing. The only time we would need them, or we would need parentheses, if it was like 2 terms, like log base b of m plus n in parentheses is different than having it without the parentheses. But for these logs, when you have something times something, if we wanted to have it outside of being logged, we would have put the m or n in front and not right after it. It's assumed that when you have things multiplied together after a log like this, it's all part of the log. I want to make sure that's clear to all of you. All right, so multiplication becomes addition, and division, so log base b of a fraction, so division becomes subtraction. The log of the top minus log of the bottom. And same thing with natural log, it's just natural logs have log. Multiplication becomes addition, division becomes subtraction. All right, other properties. And this one's really not new. We know, I'm going to go from the bottom and go up. We know that when you have a base raised to log of the same base, they cancel out, and then x would just carry down. And we use that in the bell work to solve it. So we already knew this one. Same thing for this. We know log base b of b, this x can move in front of the log, and log base b of b just becomes 1, and 1 times, well, whatever we moved in front is just that. So again, we knew this one already. We already know log base b is equal to 1. We use that in bell work. And log base b of 1. So whenever you have log of any base of 1, it will always equal 0. So here's another property for you. Any log with any base of 1 is always equal to 0. Same thing for natural log. Natural log of 1 is always equal to 0. If you forget, you just type it in, hit enter, and it'll tell you it's 0. So go ahead and type in log of 1, hit enter, you get 0. Type in natural log of 1, hit enter, you get 0. Over here, natural log of e, this is equal to 1, which makes sense because, remember, natural log is log base e. And log base e of e, well, e and e would match, just like over here, and that equals 1. Natural log e to the x, again, x moves in front to be by itself, and natural log of e is, we know, is equal to 1, and 1 times x is just x. Over here, e raised to the natural log of x. Similar to over here, these cancel out, and the x would just carry down. So this page is starred. Make sure you have this either in front of you or written down your notes to reference to if you have trouble memorizing these. But hopefully by the end of this unit, you'll have all of these memorized, all these properties. So this page is really important to know and have written down somewhere. And also this page, that's why I have a star. All right, so let's expand. So we're going to use this expansion property to expand this first one. Now, when you ever get these problems, you always want to rewrite all your numbers as prime factors with exponents. And you also want to rewrite any radicals as a quantity raised to some power. All right, so how can I rewrite 6 with prime factors? Yep, 3 times 2 or 2 times 3, it doesn't matter. So 6 is just 3 times 2. All right, we have prime factors now with exponents. And now we want to, well, expand it. So what should I write as my answer? Natural log 3 plus natural log 2. Yeah, that easy. So your final answer shouldn't have any exponents, and it should only have prime factors of your logs. Good. All right, next one. What can we do? We can move the exponent, the x, in front. Yeah, that's one of the properties. Is 3 already prime? Yeah, so there's nothing to do. So all we can do is just move this x in front. And that's it. There's nothing else we can do to that problem. So it's already expanded. So again, your final answer should be no exponents. And your logs and natural logs, so these numbers right here, should all be prime. The number in front, the coefficient, it's possible it won't be prime, and that's okay. It's just we care about this. All right, let's try another one. All right, so let's look at this problem. 4 and 7, are these prime numbers? Yeah, not the 4. So how can I write it? So I can write it as 2 times 2 off to the side. Yeah, 4 is 2 times 2. So I can write it as 2 times 2, but we want to write it as prime numbers with exponents. So rather than write 2 times 2, what should I write? Yeah, 2 squared. So we want to make sure all our numbers are prime numbers with exponents. So we don't want to write that as 2 times 2. We want to write it as 2 squared. All right, so we have everything written as prime numbers with exponents. Now what can I do? Yeah, we're going to expand it with division. So the fraction multiplication, sorry, the fraction division becomes subtraction. So we're going to write the log of the top minus log of the bottom. All right, are we all done? Yeah, we're not. What's next? Yeah, move the 2 in front. All right, we done now? Yes, we are. Expanded, we don't have any exponents. All the log of stuff is all prime. It looks good. Right. So here's a question for you. Can we move this 5 in front of this natural log? Is that allowed? Why or why not? Yeah, so Brady feels like no. Now let's say that 12 wasn't there and it was natural log of x to the 5th. So let's pretend that 12 is not there. Could we then move the 5 in front? Yes, we could. So we can only move exponents to the front of logs or natural log if the exponent is the entire quantity. So, for example, let's say we had parentheses around 12x. Now, can we move the 5 in front of the natural log if that was the original problem? Yes, we can. Absolutely. But because the exponent is only attached to the x, we are not allowed to bring that 5 in front of the natural log. And again, if it makes you feel better for whatever reason, people's thinking towards a problem changes when you do this. Can I now, looking at it like that, can I bring the 5 in front of the natural log? Yeah, the answer is no. Because again, we are the exponent is still only attached to the x. It's not attached to the entire quantity being 12x. Right. Okay, with that, all that fun stuff said, what is our first step in this problem when we want to expand it? Yeah, we want to get prime factors with exponents of the 12. So what should we write in place of 12? 3 times 2 squared? I agree. And just to show my factor tree for those that are, oops, I'm having a really bad habit of not picking up my pen today. So we have 2 2s and a 3. And it doesn't matter the order. You can put 2 squared first and then the 3, or the 3 and then the 2 squared. It doesn't matter. I'll do what all of you said in chat and put the 3 first. So we got 3 times 2 squared times x to the 5th. All right, we got prime factors with exponents. looking good so far. Yes, and now we can expand it. Yeah, we can expand with addition. So what should we write? Multiplication becomes addition. Yeah, we're going to have three terms, natural log of 3 plus natural log of 2 squared plus natural log of x to the 5th. I agree. Okay, what's next? Yeah, now we move the exponents in front. Right. All right, are we done now? Yes, we are. All right, let's try a harder one. All right, everyone try both of these. And a little hint for you, how can I write a square root as a quantity with an exponent? How can I do that? Nope, that's inverse, not the same thing. Nope, that's also an inverse. Yeah, Isabel's correct. 1/2 power. And we reviewed that earlier this week. So let me just write it up top. Remember when you have like an index of n and you're doing the nth root of, let's say, I don't know, b? It's the same thing as writing b raised to the 1 over n power. Remember that from earlier this week? Or maybe it was Friday, I don't remember. You also learned it back in like at least maybe your freshman year, maybe earlier. And when I say freshman, because we do have a ninth grader in this class, your freshman level math. Yeah, I just wanted to review that because you need to use this math property when starting this problem. But yeah, go ahead and do both of these problems. Give me a green check when you finish both of them. Right, what did everyone get for the first one? Natural log of 2 minus 3 natural log 3. That looks correct. Yeah, very good. Very good. And what about the harder one? What did you get for that? So Enzo, 8 is not prime, so we have a problem there. Ooh, Isabella, 2 to the 6th power is definitely not 8. Not sure how you got 6 in front. Yeah, so what Brady has, the 3 log 2 plus 1/2 log a minus 1 is correct. So how did you guys get a 6? Some of you got a 6 in front. What's going on there? Oh, you put everything over 2. So let's work this one out. So okay, I see that. So remember, the 1/2 power is only to the a minus 1 and not the entire thing. So let's see our flow of work. So we all know that 8 is 2 cubed, right? And then we know that the square root becomes that quantity to the 1/2 power. All right, so everyone should have got this step correct. And I'm confident that all of you did. Now, are we allowed to put this 1/2 power in front of this log? Some of you think yes, because that's what you did apparently, right? But you can't. Remember, this is, in order to move an exponent in front, it would have to be the entire quantity. For example, let's say I had, let's say it was log of all of this stuff raised to the, I don't know, 5th power. Then in this situation, we are allowed to move this 5 in front of this log. But because your log of 2 cubed times a minus 1 to the 1/2 power, the exponent isn't for the entire piece that you are logging. It does matter. Does that make sense, everyone? Everyone follow? Okay, so let's go back. So what should we do next? Yeah, we expand with addition. So we get log base. Oops. What am I doing? What am I doing? You know, the undo tool doesn't actually undo. When I click undo, it like undoes part of what I wrote. It's really weird. Neuro is so good. Oh my gosh. All right. Now what can we do? Yeah, now we move the exponents. And we can see here, see how this 1/2 exponent is the entire quantity? So it's log of the entire quantity to the 1/2 power. in this scenario, yes, we are allowed to move the 1/2 in front of this log. That is an A, by the way. All right, are we done? Yes, we are. We can also rewrite this problem slightly different. Isaiah wrote it this way. He just had the beginning wrong. So log 3 log 2. And how can I well, I kind of gave it away already because Isaiah did it this way. So that 1/2, we can multiply it and we can stick that log on top of that 2. Log a minus 1 all over 2. So this is another way we could rewrite the final answer. Just off to the side, for example, if I have like 1/2 times x, that's the same thing as saying just x over 2, right? We're just showing it differently. I did want to show this because we have to use this idea, this principle of factoring out this. So whenever we see this over 2, sometimes we have to pull it out in front, especially when you have to go backwards. Like if we go from this expanded form and we want to go to the contracted form, we would have to factor this out in front to be a 1/2, then move everything back to the exponents, and then combine everything to be multiplication, and then do 2 cubed is 8, and rewrite this as a radical. So that'd be just everything reverse order. All right. Everyone, I'm going to skip, for time's sake, I'm going to skip these two. And let's go to this one. Everyone do this problem. When you have your answer, give me a green check. Yeah, he's a little needy. He waits until I sit down. I stand in the morning, all morning, and then after classes I lower my desk and I sit down, and then he likes to sit in my lap the rest of the day. And everyone's done. What did everyone get for their final answer? I do, Enzo. Yeah, so if you didn't know, you guys can like build your own motorized desk. So the one that I have, I bought the frame, the actual like metal frame part separately, and then I ordered a piece of butcher block from Lowe's, which is like I don't know, it might be 7 feet by like 3 feet. That's already pre-stained, and I attached it to it, so I have a really sturdy desk. 3 natural log 3 plus 4 natural log x minus. All right, so Enzo, the only thing I would change about your answer is lose the parentheses around the first two. You don't need them, but you definitely need it around the second part because you are subtracting that entire quantity. Yeah, good. All right, so who got that answer? And if you forgot these parentheses, your answer is wrong. Without these parentheses, your answer is completely wrong because remember, we are subtracting this entire piece before you expanded it. So when you expand it, you can't forget the parentheses. And that's probably the biggest mistake people make on a problem like this is they forgot these parentheses and it does change your answer. Did anybody distribute that negative? You are allowed to do that. It's okay. You didn't know, but you are allowed. So you could rewrite this answer as this after you distribute this negative. I don't know which form they would want to see on your quiz or your test. I guess we'll have to wait and see, right? They may just want it like this, or they may want you to go one step further and distribute that negative. Yeah, order. Well, yeah, it well depends. Like you can have these first two terms can be switched, and then these two terms can be switched. But like I couldn't, you really don't want to like reorder your plus and minuses after you do that. Does that answer your question? Okay. Let me just quickly run through this problem. We wrote everything as prime factors with exponents. So we have natural log of 9 is 3 squared. 20 is 5 times 4 or 5 times 2 squared. Doesn't matter the order. 2 squared times 5. All right, and then from here we know that a fraction becomes subtraction, so we have natural log of the top stuff minus the natural log of the bottom stuff. And then we're going to expand one more time. We know multiplication becomes addition, so that left part, our first term, becomes natural log of 3 squared plus the natural log of x to the fourth minus, and then I'm going to go ahead and in the same step, hope you're okay with this. Instead of writing the exponents, I'm going to move the exponents in front. So that puts a 2 here, and then we put a 4 right here. Is everyone okay with that? Of me doing those two things at once? Just trying to save time. Ideally, you don't really want to do those things in the same step when you're first learning this. And then on the second term, the minus ln 5 times 2 squared, again, becomes addition, natural log of 5 plus the natural log of 2 squared. And again, I'm going to move the exponent in front in the same step. But don't forget, because if you forget the parentheses, it looks like you are subtracting this, and then when you actually go the other direction, you'll be doing, all right, multiplication, multiplication. All right, here's the division part, but then you're multiplying again. So this would actually be going in the numerator. The 4 would, and you would have 36 on top instead of 9. So you cannot forget the parentheses in a problem like this. And then we can distribute that negative if we want. It doesn't matter. All right. Good. We have more time than my last hour. All right, let's go the other direction. So you just do everything reverse order. All right, so looking at this problem, what should we do first? These are, in a way, easier. Yeah, so move the exponent. So move the coefficients back to exponents. Good. So we got the log of x to the 1/2 power plus log. All right, now what? Addition becomes what? Multiplication. Yep. Are we done? Yep, make it a radical. Very good. Yeah, that 1/2 power becomes a radical. All right, we done now? Yes, we are. And if you want to put parentheses around the entire thing like this, you can. You don't have to. So if you want to do that, you can. I'm not going to. I think more parentheses just makes it look more confusing than it really is. All right, everyone try this second one on this page and give me a green check when you finish it. All right, looks like we're waiting for one more person, but I don't know if that person is here or not. All right. Yep, everyone's here. Okay. All right, what did everyone get for their final answer? Natural log of x plus 2 squared over x. So the only thing I would change about you writing it like that, Enzo, is you're missing parentheses. So it looks like you're taking the entire natural log and just dividing that entire piece by x, even though I'm pretty sure I know what you meant. Yeah, so what Isaiah wrote it would be correct. Writing it in like text left to right. Yep. So the answer is the natural log of x plus 2 squared over x. All right. Do I need to show this work, or are we good? This is a fairly simple one. I can't imagine anybody would want to see this one. All right. How much time we got? We got time. Let's do. Let's do this one. We'll do this one, and then when you finish it, give me a green check. Yeah, these take a lot of practice. The more you do, the easier it gets. Um, and then once seeing the work, you're like, oh yeah, that makes sense. Why didn't I do that? That's why you need to practice these and go through the examples in the module. It is, yeah. I try to ease us in. Sometimes we just jump in the deep end. All right, everyone's done. Anybody have an answer for this one? Just kind of curious to see what we get. Log base 2 of c squared times radical a, square root of a. Yeah, that sounds right, actually. That sounds right. So what did everyone do to I guess, set this up or start it off? What did everyone do? Yeah, so that divide by 2 becomes a 1/2 in front. Super important. Yeah, super important. Um, so, and I did kind of mention it, kind of give you a hint on this problem, basically, that we have to move this in front to be a 1/2. And I can go ahead and move this 2 to the exponent now, or I can do it second. It doesn't matter. I'm going to go ahead and just do it now. Log base 2 c squared. And then everyone move the 1/2 to the exponent. Is that right? Yeah. If you miss this part right here and bringing this out in front as a 1/2, you probably got stuck or didn't really know how to deal with that 2. All right. Now what? Now we have log plus a log. Yeah, we combine it, becomes multiplication for a single log. And in the same step, I'm going to rewrite that a to the 1/2 power as a radical, just to save myself time in writing it again. So that a to the 1/2 becomes the square root of a. And then we're done. Got that one correct. It's kind of split. Some almost got it right, some got it right, one person missed it. And my guess, for the half of you that didn't get it right, was it because of that divide by 2? But now we know, right? The more we know. The more we know. All right. I'm going to skip this one because I'm running out of time. I do have to cover the last problem. I will show the answers. Well, I'll show the answer to this one. I still got to go back and show the other ones that we skipped. I'm going to skip this one, but here's this answer. Feel free to work on it on your own time. Oh, on this problem, I do want to say something. So whenever you have like the square root of, let's say a, yeah, a, and then you're timesing it by the square root of b, well, you probably forgot this, but when you have a radical times a radical, and it's the same index being square roots, you can combine it under a single radical and just do a times b. So if you forgot that, because you do need to know that this little math property with radicals in order to actually get down to the right answer. If not, you would have radical a times radical b, and well, that's not simplified. So just want to point that out to you. All right, this problem, I believe this is actually a TGA problem. Maybe on your notes or whatever, if you print them out, you might want to write TGA question, because if you answer the TGA question in any other way than I'm about to show you right now, you will not get credit. The question says, what is the approximate value of log base 3 of 20? And some of you, Enzo, I can think of probably being one of them, will say, hey, I'm just going to type this in my TI Inspire or whatever model that you might have that can do this. And even the Casio FX 115 and 300 can actually type this in. But if you type this in, log base 3 of 20, hit enter, and you write your answer on your TGA, I will mark the entire thing wrong, because you are not doing it the way the problem was intended. In my rubric, the way my rubric is set up, I couldn't give you points, unfortunately. I give you these givens. So if I tell you that log base 3 of 5 is this value and the log base 3 of this value here is equal to, well, this answer, we want to use this to solve this. So any guesses of how we can actually approach this problem? Think about everything we learned today. Think about everything we learned today. Well, we can only use these given values to solve for this. So what can I do to this? Yeah, we're going to expand it by first writing 20 as 2 squared times 5, right? 20 is 2 squared times 5. So we got the log, oops. Of, what do we say? 5 times 2 squared, right? And then we can expand that, correct? Oh, wait, not. I said squared and wrote cubed, didn't I? Yeah, something I would do. All right. And then we can expand that like we've learned today. The log base 3 of 5 plus log base 3 of 2 squared. And I'm going to go ahead and put the 2 in front just to save myself time in writing another line. All right. Now look, log base 3 of 5 and log base 3 of 2. Hey, those are the two givens. So we're going to, well, we're probably going to do what you're thinking. We're going to replace those values with what's given. So I'm going to write log base 3 of 5 is equal to 1.465 plus, this is 2 times log base 3 of 2, which we know it's given is 0.631. 631. And then I'll just continue over here. Then we just do the math, right? Just 1465 plus 2 times 631 is 1.262. 1.262. And then add those together, what do you get? 2 point something or other? 2.727? 2.727. Yeah, all done. Okay. So on your TGA, that is how you do this problem if you want points based on my rubric. Do not type it in. You need to actually expand it to hopefully get down to what's given to you, and then replace those with, well, the values that they are, and do the math. It's a very easy problem if you know how I want you to approach it. Don't just type it in. So for this one, we do not put a fraction. Correct. Yeah, actually, yeah, good question. So the reason why we don't have a fraction is because the original problem gives you decimal values to begin with. So because of that, it is totally appropriate to have your final answer also as a decimal. All right, guys. We're almost done with this unit. We only have 3 more lessons for Unit 4. Then we have, well, your test, of course, review. And then we have the final, and then that's it. And then you get to have a break of hearing me talk about math until next term. All right, guys. Well, thanks for coming. And as always, I hope you learned something. I will see all of you on Friday after Veterans Day. All right. Have a good rest of your Wednesday.